Welcome to Revised Chemistry with Mr. B. In this video we're going to be seeing which of these reacts the quickest. 10 grams of calcium carbonate made out of large pieces or 10 grams of calcium carbonate made out of small pieces. So it's really important to take the starting mass, and then I'm going to add the acid to the calcium carbonate and start the stopwatch, and you'll notice that the mass is decreasing because it's giving off a gas. It's giving off carbon dioxide gas, and as that leaves the flask, that means that the flask is going to get lighter. So I'm going to leave it reacting for 30 seconds, and our control variables are the concentration of the acid. We're keeping that the same. We're also keeping the same mass of the calcium carbonate. We're keeping that at 10 grams each time. So after 30 seconds, we take down the new mass, and the difference in mass is going to be the same as the mass of carbon dioxide given off. I'm then going to repeat it with the small calcium carbonate pieces. So once again, I've made sure I've already taken down the mass at the start, and I'm going to time it for 30 seconds. Now you'll notice that I've actually put a cotton wool plug in the neck of the flask. Now we need to do that to make sure that any of the acid spray doesn't spray out, because that could be a hazard. And we're also, by putting cotton wool in the neck, giving chance for that carbon dioxide to leave the flask, and therefore the mass will start to decrease, and that will allow us to track the rate of reaction. So after 30 seconds, we take down the new mass. So you can see for each type of calcium carbonate, the large and the small, I've got the starting mass, the end mass, and the difference in mass, which is the mass of carbon dioxide produced. I've also jotted down the time taken, which was 30 seconds each time. We need to remember to calculate the mean rate of reaction. It's the amount of product made divided by the time taken. So for the large calcium carbonate pieces, we made 0.01 grams of carbon dioxide in 30 seconds. So 0.01 divided by 30 is 0.0003. For the small pieces, we made 0.34 grams of carbon dioxide in 30 seconds. So 0.34 divided by 30 gives us a rate of reaction of 0.01. Now the units for the rate of reaction in this case is going to be grams/seconds, grams per second. So we can see that the small pieces of calcium carbonate reacted much faster than the large pieces. So why is it that that happens? At this point, we need to consider the surface area of the different sized solids. So imagine if we had a piece of calcium carbonate that measured 10 centimeters by 10 centimeters by 10 centimeters. So it was all in one big lump. Now, if we went through and worked out the surface area of that cube by working out the area of one side and then multiplying it by 6 because it's got 6 sides, we'd find out it had a surface area of 600 centimeters squared. Now, if we had the same amount of calcium carbonate, but just chopped it up into 8 smaller pieces that each measured 5 by 5 by 5, and if we did the whole calculation again, looking at the total surface area of all 8 cubes, we'd notice that the surface area is now 1200 centimeters squared. So without getting bogged down in the maths of it, the big point I'm trying to make is as you cut something into smaller pieces, the combined surface area of all those pieces increases. So the smaller the pieces get, the bigger the surface area. This is a good point to check our understanding. So if we have larger pieces of chemicals, they have a combined smaller surface area. If we have smaller pieces of chemicals, they have a larger surface area altogether. So if we had something in a powder, which is tiny pieces, it's got an even bigger surface area. So how do we explain the difference in the rate of reaction that we saw with the experiment? Well, smaller pieces or powder have a higher rate of reaction. That's because they've got a larger surface area, so there'll be more frequent collisions in a set time. Larger pieces have a lower rate of reaction because they've got a smaller surface area, so there will be less frequent collisions in a set time. And these are ideal answers to a 3-mark question on your exam, so make sure you actually memorise this information. On your exam, you could be asked to calculate the surface area to volume ratio of a cube, especially if you sit in the higher tier paper. So first we'd need to calculate the surface area of the cube. And the surface area of a cube is the sum of the areas of its 6 sides. So if we imagine the side that's shaded in, the area of one side is going to be 7 by 7, which is 49 centimetres square. And so the total surface area, when we remember there's 6 sides, is going to be 49 times 6, which is 294 centimetres square. Then we need to calculate the volume of the same cube, and we do that by multiplying the length times the height times the width. So that's 7 by 7 by 7, which is 343 centimetres cubed. So to calculate the surface area to volume ratio, we divide the surface area by the volume. So that would be 294 divided by 343 gives us a surface area to volume ratio of 0.73. If you found the video useful, please do take a second to give it a like. Thank you for watching.